Video for complex numbers. This is Miss Riley's maths videos, and this is a video of complex numbers for Leaving Cert ordinary level. And I'm looking today at the idea of the modulus of a complex number, and it's probably a should know rather than a could know. It's not difficult to calculate. What I find is that it's difficult to recognize when you're being asked for what the modulus is. So we'll talk about that in a minute. The modulus of a complex number is the distance of that complex number from the origin on an organ diagram. Is probably the easiest way to visualize it. So here I've got an organ diagram. There's my real axis, there's my imaginary axis, and I've plotted some of these complex numbers. I've plotted 2 plus 5i, 6 plus 3i, 0 minus 5i, and minus 4 plus i. And I've just plotted them there, and you can see that I've drawn a line connecting them to, this is what's called the origin, the center point of that organ diagram. In coordinate geometry and in organ diagrams, this center point is called the origin. So the distance from 2 plus 5i to the origin, that's the modulus of that complex number, is the distance there. The distance here between the origin here and this complex number, minus 4 plus I, and this distance here between the origin and 6 plus 3i, distance between the origin and 0 minus 5i. They're the modulus of those complex numbers. So that formula that we're going to use here, which is to calculate the modulus of a complex number, this is the formula we're going to use. So this is the general form of it. It's kind of explaining what it looks like as a formula. If a plus bi is a complex number, then a plus bi with these two straight up lines. Those two straight up lines mean the modulus. So when you see those two straight up lines around a complex number, this is what they mean. They mean the modulus of a complex number. And to calculate the modulus, so the two straight up lines again there, we have to calculate the modulus of a plus bi. We square root a squared plus b squared. So we first of all square a, add on b squared, so a squared plus b squared, and then find the square root of the answer. Now where this is coming from is from Pythagoras' theorem. You don't need to know this, I'm just briefly explaining that if this was our complex number 6 plus 3i, the distance from the complex of this complex number from the origin, as you can see, is the hypotenuse of a right angle triangle. And if you remember from Pythagoras' theorem, if you've got to find the hypotenuse, it's this side squared plus this side squared equals this side squared. So c squared is equal to a squared plus b squared. That's Pythagoras' theorem. So c, if I square root both sides, c is equal to the square root of a squared plus b squared. That's where the formula comes from, but you don't have to worry about it. All you need to know is how to calculate it and to know that it means the distance. So here's our four complex numbers. Let's see which one is furthest from the origin. Let's see. So z1. So modulus of z1, that's how it would be written, is going to be equal to the square root of this number squared, 6 squared, plus this number squared, 3 squared. So the square root of 36 plus 9, the square root of 45. So you saw that all I did was take the real number squared and the number in front of the I, what we call the coefficient of the I, and square it. Added them together, and it's the square root. And the square root of 45, according to my calculator, is 6.7. So the modulus of z1 is 6.7, or the modulus of z1 is root 45. The modulus of z2 is the modulus. See the way the lines are written, the two straight up lines? That means the modulus of z2 is going to be the square root of 2 squared plus 5 squared. So the square root of 4 plus 25, so the square root of 29. So I can see this is going to be closer, isn't it? Let's get it as a decimal anyway. Modulus z2, modulus z2. So root 29 is 5.4. So that's the modulus of z2. Modulus of z3, well there's z3. Modulus of z3 is the modulus of minus 4 plus I. Now, with negative numbers on your calculator, it's always best to put those negative numbers in brackets because the calculator gets confused. And I is the same as 1i. So I'm just going to pop a 1 there, 1i. So it's minus 4 squared plus 1 squared. So the square root of 16 plus 1 which is root 17, because remember, minus 4 squared is minus 4 times minus 4, which is plus 16. So the square root of 17, which is 4.1. So modulus Z3 is the square root of 17, which is 4.1. And finally, the modulus of 0 minus 5i is equal to, that's the modulus of Z4. So that's going to be equal to the square root, my pen's run out, the square root of 0 squared plus minus 5 squared, which is the square root of 0 plus 25, which is the square root of 25, which is 5, which of course makes sense, doesn't it? Because if we look at this complex number here, this is Z4, this is Z4. That is a distance of 5, isn't it, from the origin? It's just straight up to the origin from there, and that's 5 units down from the origin, so that's a distance of 5. That's what modulus means. And then just to finish up, what they might do is they might ask you something like, find the modulus of Z1 plus Z2, where Z1 is 6 plus 3i, and Z2 is 2 plus 5i. So what they mean there is to add Z1 plus Z2, first of all, is equal to 6 plus 3i plus 2 plus 5i is equal to 8 plus 8i, and then find the modulus of that after you've added it. So that's going to be the square root of 8 squared plus 8 squared, so the square root of 128, which would be whatever. Square root of 128 would be 11.3. Okay, so that's the modulus. The key thing to recognize it is these straight up lines. Look, those straight up lines. That means modulus. Straight up lines. Straight up lines. These all mean modulus. That's what you're looking for. When you see it in a question, that's what it means. And the formula is this one. Okay, so the modulus of a complex number, to calculate that, that's what we do. Okay, I hope that's useful. Take care. Bye-bye.